Hi everyone, in this lesson I'm going to be discussing the various probabilities involved in getting different poker hands when we're using a standard deck of 52 cards. Now this diagram is laid out with all of the 52, so let's just get a bit of terminology. First, we call the different suits, these are the suits, so that's the spades, the hearts, the diamonds and the clubs. And then these ones, there are 13 different ranks for each suit. So you've got ace, then numerically 2 through to 10, then a jack, then a queen, then a king. So there are 52 distinct cards in a standard deck. We don't worry about the jokers when we do these sorts of things. So there are 52 unique cards. But of those, there are 4 aces. And then the aces, of course, there'll be an ace of spades, an ace of hearts, and so on. And now, let's move on to, first of all, let's consider if we were choosing 5 cards at random from the deck, how many different ways could that happen? Well, there are 52 cards, and we would choose 5. Now, you can plug that into your calculator. Of course, you could use the formula if you want, but unsurprisingly, there is a very large number of ways of doing this. It's 2,598,960 possible ways of choosing 5 cards from the full deck of 52. Now, that's an important number because that's going to end up being the denominator in all of our probabilities. If you like, this is the number in the sample space. And, well, there's no way I could write them all out. But, for instance, your first hand might be, well, I'm not going to even bother writing it down. The sample space is truly enormous, and it would be virtually impossible without a machine, of course, to write them all down. And why would you bother anyway when we can calculate it with 52C5? So that's the sample space. There we go. Now let's move on to the different types of poker hands that you can get. Let's start with a really quite a straightforward one. Let's talk about getting a pair, just one pair. So I'll designate this by writing A, B, C, D. Now I want to stress that this A does not stand for ace. This just stands for different ranks of cards. Because when we're talking about a pair, we might be talking about a 2 of diamonds and a 2 of hearts. It's a pair of 2s. We don't care about the suits as long as the rank is the same. Then the B and the C and the D represent different ranks. So this might be both rank 2, and then this one might be a 5, this one could be a king, and this one could be a jack. It really doesn't matter as long as they weren't 2s, otherwise it's no longer a pair. Now we'll talk about 3 of a kind later. So how do we calculate the number of possible ways of selecting a hand that had this pattern to it? Well, start by looking at the ranks here. So if I have 13 different ranks to choose from, and I'm looking at the pair, they have to be of the same rank. So I'll just make a little note here that this will tell me the number of ways to choose the rank of the pair which is represented in my list by A. Now, I'll go back to my diagram for a minute. Let's just, for instance, say that by random I chose rank 7. So these cards here it's going to be the pair is going to be these. Now, how many of these cards are there? 4, and I need to pick 2 of them. So to select from those subset there, I have 4 choose 2. And that will be the suit of A. Now that takes care of the pair. When it comes to the second, or the next group, the 3 cards here, well then I need to choose 3 different ranks. So it's going to be choose 3. But I no longer have 13 ranks to pick from because they have to be different from the rank of cards represented there by A. So there's really only 12 others to pick from. If I go back to my diagram, I can't choose a 7 because that rank is already used. But I could choose from any of the other 12 ranks available. And there are 3 cards to choose. That's nice. I'll make a note here. This is the rank of ranks of B, C, and D. Now, when it comes to, say, card B, perhaps card B is going to be of rank 4. Now, how many 4s are there? Well, there are 4 cards in that rank, and I only need to pick one of them. So for card B, I have 4, choose 1, and that will be the suit of card B. But of course, I also have to worry about how many ways I could choose the suit of card C. And finally, there are 4 choose 1 ways to get the suit of card D. So there's quite a bit of complexity involved in just getting a pair of cards. Now, when you plug all of that into your calculator and crunch the numbers, this comes to the rather impressive total of 1,098,240 cards. And that would be the number of ways, let's just make a note, that's the number of ways to get one pair. So if I want the probability of getting a single pair when playing poker, we know the rule, number of ways that I can get my favourable outcome divided by the total number in the sample space. And when you do put the 1 million and you divide that by the 2.5 million, you find that this comes to a bit over 42%. So there's actually, it's reasonably likely that when drawing 5 cards at random from the deck, that you'll get a single pair of cards. Now, of course, that's not the only possible pattern that we could produce here, is it? We could perhaps get, well, what about 3 of a kind? So what would that look like? Well, there would be 3 cards of the same rank, which I'll designate symbolically by AAA, and then I would have 2 cards of different ranks, which I'll call B and C. Now, looking, let's just divide this down the middle. Looking at the 3 cards of the same rank, there are 13 ranks to choose from, and I need to pick just one rank to represent those cards. Rank of A is what I'm talking about there. Now, once I've chosen a rank, there are 4 different suits available, and I need to choose 3 cards. That's the suit of A. Now I come across here to my next 2 cards, which don't match. There are 12 ranks available, and I have to choose 2 of them. So this is the ranks of B and C. Now, when it comes to B, there are 4 different suits, and I'm choosing only 1 card. So that's the suit of B, and likewise, 4 choose 1, that's the suit of C. Now you can get the pattern of what's going on here. I'm splitting the choices into ranks and suits for each of the different subsets in my hand there. Now once again, crunching the numbers on this, I'll let you check this on your calculators. I've just done this earlier. It's 54,912, and then if I convert that to a probability, so the probability to get 3 of a kind, once again dividing by the total number of in the sample space, I find that is around about 2.1%. Quite a bit rarer occurrence than getting a pair. Obviously in poker, 3 of a kind beats a pair because it's more unlikely that you'll get 3 of a kind. Now, there's lots of other possible poker hands that you could be looking at. That's just a couple of examples of what you could do. And I'm certainly not going to do all of them, but that's an introduction. There's plenty of sources out there on the internet that you can look at to find these things. But when I reviewed a few of them, I find that their explanations were rather thin. So they might have had the appropriate calculation and the right number. But if you don't understand the basics of the details here of what's going on, it's a bit hard to follow some of those things. All right, this video is long enough for now, and that's a very short intro to finding the probabilities of different poker hands. Like I said, we've only done a couple of different, not exhausted, but it's an introduction only. Thanks for watching.